yourself. Hey guys, I'm here with Coach Split. Coach Split knows a thing or two about a thing or two, so I got a question for you, Coach Split.
Sure, Fish.
You ever in your phone type in directions on how to get somewhere, like go into Google and say I need to get here, and it spits back how you get there?
The thing that says MapQuest?
Absolutely, MapQuest. How does that work?
I type in an address and I push enter or give me the directions, and it gives me the directions.
Do you know how it tells you where to go? Do you know exactly how it can tell you how to get to point A to B?
Many people who have programmed that individual site. I'm sure that all those people had something to do with it.
They all program. They know exactly every street. They know where you're going.
There are professionals, there are people out there who do this for a living and find every street in the United States and the world.
Awesome.
That's what I know.
You heard it right there from Coach Split. All right, guys, this video is going to get into basic Earth coordinates, and what we're building up to is how to read latitude and longitude, and also how a GPS works. Because as Coach Split kind of demonstrated for us, we know these things and we use these things every day, but we have no clue how they work. All right, so let's get into it. By the time you're done with this video, you should take notes on three things. What are hemispheres? Why are they important? What's latitude? Why is it important? And what's longitude? And why is it important? All right, so let's go ahead and talk about some basic coordinates. This is a circle to represent the Earth, and we're going to go ahead and split that circle right in half, using that line right there. And what I just drew on there was the equator. You've probably seen the equator on a map splitting in half, or a globe splitting in half, and the equator actually has a very specific purpose. What it does, it breaks our Earth into two distinct hemispheres. Now, a hemisphere just means a half of a sphere. It's a little bit different than what we're looking at right now. A sphere is a three-dimensional circle, like a ball. This is just a circle. It's flat. It doesn't have that third dimension, but I think you can picture it based on what you've seen from globes and stuff like that. Well, the equator, what it does, everything above the equator here is in the northern hemisphere, and everything below the equator down here is in the southern hemisphere, and that's really the purpose of the equator. It's to break our Earth up into two distinct hemispheres, northern and southern. Now, there's another line that splits our Earth in half, like the equator, but it goes up and down instead of side to side. And that line's called the prime meridian. The prime meridian runs through a city called Greenwich, England. And what it does is that it splits the Earth in half to an east and west, where everything on this side is east and everything on this side is west. Now, what we need to keep in mind here is that this is a sphere, so it reaches all the way around. Let's go ahead and take a look at another diagram to kind of help us out with that. All right, so here's that line, that equator line again. I drew the back half dashed to show you that this is supposed to be going around and behind, so behind the planet. So I tried to make a sphere here. So our equator, again, wraps all the way around the Earth, goes from all the way to the front to all the way to the back, and it splits everything up in a northern and a southern half. Everything on the top is in the northern hemisphere, and everything on the bottom is in the southern hemisphere. Let's go ahead and take a look at that prime meridian line again. Here it is, and I tried to draw that 3D effect again using the dashed line to represent going behind the Earth or to the other side of the Earth. And we have this line that goes from here all the way down here. This is really the prime meridian. I don't want you to get the idea that the prime meridian wraps around. That's the difference between the equator and the prime meridian. That's one of the differences. The equator does wrap all the way around the Earth, but the prime meridian doesn't. Once we learn what a meridian is, that'll make more sense. But what we have here is everything on this side wrapping around to right here. Everything over here is on the east side of Earth. And everything on this side, wrapping all the way around to this line, is on the west side of Earth. Because we do have to think about this as a sphere. Taking a look at both together, notice that we have our north and our south, where everything above the equator in this area is all in the northern hemisphere. And everything down here below the equator is in the southern hemisphere. But then we can also talk about the eastern and the western. Everything wrapping around here is in the east, and everything wrapping around here is in the west. And I'm drawing these curves to show that we should be going around a sphere, because this coordinate system is for a spherical planet. All right, guys, I'm here with my special guest. This is Mr. Herbst.
Hey, Mr. Herbst here.
This is Mr. Herbst. He's filling in for Miss
McLeod.
Miss McLeod.
Yep.
For Miss McLeod this semester. Anyway, he's here to help us out a little bit. I told Mr. Herbst that we're talking about basic Earth coordinates, and we're talking a little bit about hemispheres, equator, prime meridian, stuff like that. Now we're getting into latitude and longitude. You've heard of latitude and longitude, right, Mr. Herbst?
Oh, yeah, of course.
I'm sure everybody has. Especially if you've maybe used your phone, GPS, something like that. And I'm sure at some point you learned that latitude was an angle that was measured above or below the equator, and that longitude was an angle measured side to side from the prime meridian. But I got a question. Let's go ahead and take a look. How many points are in an angle?
You got to have 3.
Right. It's between 3 things, and then you get your angle there. 0, 90, 180, something. But it's between 3 different points, like this. We got an angle here. I got a point here, and I got a point right here. So that's an angle, right? About 45 degrees or so. Well,
sure.
Let's take a look here. We got a model here of the Earth, and I've started to block us over here. Let's see if we can do about that. I got a model here of the Earth, and I drew on the equator right here. That's what this is. And let's say Mr. Herbst gets in his little airplane, and he cruises, and he stops right over here at this point. So here's Mr. Herbst hanging out right here at this X. Now,
It's like a nice tropical area to be
living. Love it. It's much better than the winter we have here. But take a look here. Take a look. You're now above the equator this far. Now let me ask you again, Mr. Herbst. How many points do you need to measure an angle?
Trace. We need 3.
3. How many points do we have?
Looks like we got 1 there.
Well, we got 1 here. We got 1 other, though. We can't ignore 1 other. There's 1 more point. It's right here.
Oh, okay.
It's right there. So then here's that question. Where's that 3rd point?
I'm going to say, what about the North Pole?
Now, if it's at the North Pole, that's way up here, right? And that's just going to mean we got a straight line going all the way on down like that. We got this big old straight line going from the North Pole all the way on down to the equator. And that means that our angle right here is 90 degrees, right there. And that would mean that anywhere you are on Earth, no matter where you are, you're going to have an angle of 90 degrees. So that would mean that every latitude on Earth is 90 degrees. So that doesn't exactly work.
Yeah.
We got to find that 3rd point. And this, to me, is always one of the most confusing things about latitude and longitude. Until I learned where that 3rd point was, I didn't truly understand what latitude and longitude were.
Fish, I'm kind of thinking, what about if we go through the center of the Earth?
That's perfect. That's exactly what it is, the center of the Earth. That's what we're looking for. Now, we got a problem, though. With this model, I can't show you the center of the Earth. I'm not going to cut this thing in half, and we're not going to cut the Earth in half to show you.
We like where we live.
I like where we live. I don't want to lose all that land mass. 71% of the Earth, is oceans. We only have, 15% of the Earth on land. That's a lot of, 7 billion people. That's not a lot of land to fit that, to fit all the people on there. So what we need to do is we maybe need to find a model to show us the center of the Earth and exactly how we can measure latitude from those 3 different points. All right, guys, so, we just learned about what latitude and longitude are. A 3-dimensional angle measured from the center of the Earth out to somewhere on the Earth, above or below the equator. We had that black globe over there to help us out, but it failed in that black globe couldn't get us into the center of the Earth.
Don't want to cut it open.
Yeah, we don't want to cut it open, So we went to our friends on the internet, and we borrowed a little diagram from them, and here's what we got. Mr. Miller, can we demonstrate for these guys what latitude is?
I think that we can.
I think we can. What do you think, Mr. Herbst? We on it?
I'm down.
Done.
Well, we needed 3 points, right?
Yeah.
I think we needed 3 points. So one of those points was going to be the equator. That was the starting point
That's
right
that
here.
guy right there.
Second, what was the second point we had, Mr. Herbst?
Well, wherever we're standing.
I think wherever we are. That's what we want to know is where we are, right? So I'm going to say I'm right here, right about New York there. And then the problem was we couldn't get to the center of the Earth. So the center of the Earth would be right here. So here's our 3 points. So if I'm going to connect these, okay, I'm going to connect New York to the center. And I'm going to connect the equator to the center. So this right here forms an angle. This gap, okay, right here, we're going to call that theta.
Theta? You
just
pulled out
I just dropped a Greek
theta,
letter.
a Greek. You're dropping it. You're dropping the Greek.
Stand back because you might get hurt.
Oh, my gosh.
Let's take it a step further, guys. What if we actually try to figure out how big that angle is just by eyeballing it? Just a rough estimate. What do we think?
Well, let's see. Let's throw 90 degrees on there
Okay.
because I always like to have that 90 degrees as a
Okay,
reference.
so I know that this right here is 90 degrees.
That
Okay,
nice
a
straight
straight
line.
angle
That
right
nice
here.
straight angle right there.
Right, beautifully straight. Okay.
Well, it's going to be less than 45.
Right, this would
because,
be half. So
Half of that 90 would be 45, and we're a little
42.
less than that half.
Let's call it
so-
42. New York. I
42.
think New York's at 40 degrees north. 40 degrees north
Yeah, that's
latitude.
about right there.
Right there. Now, how about Chicago? Where's Chicago on that
So
map?
Chicago's going to be about right here.
You know what? That seems to be on the same line.
So if I was traveling...
If you extend that out, we seem to be on the same line here.
Yeah.
And take a look. Look at the line above it. Can you trace the line
This
above
one right
it?
here?
Yeah. Maybe switch colors real quick.
Okay.
Show them the...
So for this right here...
Mr. Herbst, you see where I'm going with this?
Yeah.
Look at those two lines there. What do you notice about those two lines, guys?
Well, I got to say, based on what I know about math, those two look like they're both what we call...
Parallel.
Yeah.
Right.
And you know what? That's a really important point because lines of latitude have another name. They're called parallels. And we got to get to know that. A parallel is any two lines that don't cross. And lines of latitude are also called parallels. There you go. That's pretty nice. See, now I learned something. And we're learning.
That's what we're here for.
Now, how about longitude?
Longitude, okay.
Does it work the same? I mean, let's take a look here.
Okay. So let's see. Latitude was going up and down here. Longitude, we're going to go this way. We're going to go side to side. So
is there anything in common though with latitude and longitude? I mean, I know it's an angle. They're both angles,
right.
but do we have anything that kind of ties them together?
It seems to me like, based on what I know, there's always some point we have to start at, always, right?
Yeah. What's that point?
I think it's going to be the center of the Earth right here.
Sounds good to me.
Right in the middle.
Even a biology teacher knows it. Even a bio teacher right there.
So I guess my second point that I want to start at, before we started at the equator here, that was 0. So there has to be some line going up and down here that's also 0.
Yeah, I talked about that earlier. That's that prime meridian line. And earlier I mentioned that prime meridian runs through a very significant city. It's called Greenwich, England. There was an observatory there, and this guy named Flamsteed figured out this whole coordinate system. But anyways, that line all the way to the right of the cutout over there, that's our prime meridian. We'll take a look at that in class in a little bit more detail, but that is our starting point. That's our 0 point for longitude. So, yep, there's our prime meridian.
Okay, so we have 0 starts here, center of the Earth here. So I want to know where I'm at here. Let's stay in Africa, and I'm going to go right here. So now we're moving side to side, so I'm curious about what this gap is. So that means I want to know this angle here. Okay, so now this time for longitude, this is going to be our angle.
Huh.
So we're going horizontally where before we went vertically.
But did we go east or west, the prime meridian there?
Well, we went to the left here, so what do you think?
How does it go? Never
eat soggy waffles. So we went to the W.
So we went to the west.
We went west.
Yep.
So wait, here's the big difference. Latitude and longitude. It measures an uppy-downy, right?
Uppy-downy.
It goes up and down from the equator. And longitude goes side to side, side to side. Right? Isn't it right?
Yeah.
Isn't that what it does?
Exactly.
But this is confusing to me. Because when I look at that globe, I see lines that go side to side, right?
Right.
You're telling me those lines that go side to side measure north and south? And I see lines that go up and down, and you're telling me that those lines go east and west. This can be really confusing. You take an easy thing here, and all of a sudden when you break it down, it can be really confusing.
I think I might have a little bit of a solution. If you pay attention to the space in between the lines, maybe now it makes a little bit more sense. If those lines that go up and down, if we pay attention to the space in between them.
So here.
Yeah.
That shows the space side to side.
That's how far I'm going
latitude.
east to west.
Well, measuring a longitude there. And then the space that goes up and down like
these
a
lines,
ladder.
the gap between
that's bringing you up or down.
Ah,
that's
makes
awesome.
sense.
That kind of clears it up for me. Hey, guys, thank you so much for sitting in today. I appreciate it. You're helping the children learn. Oh, and we're running low on batteries. So look at that.
Got to wrap up this party, guys.
Thanks for coming. All right, guys, that's going to wrap up this video. I'd like to thank my special guests, Mr. Herbst here and Mr. Miller. It was a lot of fun having them sit in. We talked about hemispheres here, north, south, east, west. Talked about latitude, longitude, the difference between those angles. Make sure you got some really good notes. Again, as always, if you have any questions, please feel free to send me an email. I'll get back to you right away, or just ask me in class. Go Pirates!